Hello third year, welcome to this week's first lesson. We are continuing on from last week and we are looking again at chemical formula. This time we are looking at chemical formula using Roman numerals. And the aim for this lesson is for you guys to be able to use Roman numerals to write the chemical formula of different compounds. Hopefully by the end of the lesson you will be able to explain that transition metals can have a range of valencies and that these valencies are shown using Roman numerals in the name of the compound. You should also be able to tell me what each of the Roman numerals mean, which number they represent, and then use them to work out the formula of compounds which have transition metals in them. Now just before we move on to using Roman numerals, I want to take a step back and just remind you of the SVSDF method of using chemical names to reach chemical formulas. The first example we have here is sodium fluoride. So our step one is our symbols. Our symbol for sodium, if we consult our data booklet, is Na. And the symbol for fluoride, or fluorine, is F. Sodium is in group 1, its valency is 1. Fluorine is in group 7, and group 7 elements also have a valency of 1. We then swap these valencies over. Can we divide 1 and 1 and make them smaller? No. So it remains 1 and 1. And our formula then will just be NaF. And here we've used the SVSDF method. So we'll do it one more time. So step 1 is symbol. The symbol for aluminium is Al. The symbol for oxygen is O. Step 2 is valency. Aluminium is in group 3, so it has a valency of 3. Oxygen is in group 6 and it has a valency of 2. We then swap the valencies round for S, bringing the 2 under here and the 3 over there. These numbers cannot be divided and made any smaller, so they remain 2 and 3. So our formula then will be Al2O3. So now that we have refreshed our memories on our SVSDF method, we can now move on to chat about Roman numerals. Now remember guys, when we see this green man in the corner, it means we need to be writing this stuff down. So grab your jotter, take the title Roman numerals and make some notes. So the metals that we have talked about in terms of chemical formula so far are our group 1 and 2 metals. Now group 1 metals will always have a valency of 1 and group 2 always have a valency of 2. And we've also discussed group 3. They always have a valency of 3. Our middle block of metals are transition metals. They sometimes have more than one possible valency, depending on the compound that they are found in. Now the valency is given as a Roman numeral in the name of the compound. And as I said, this is usually in the case of transition metals. So the example we have here is iron 2 chloride. Our iron would have a valency of 2. We find the valency of chlorine in the same way as before. So let me demonstrate. We would use the same method, SVSDF. Our symbol for iron is Fe and the symbol for chlorine is Cl. Now this Roman numeral for 2 tells me that iron's valency is 2. We find the valency for chlorine in the same way that we did in the last lesson. Chlorine is in group 7, so its valency is 1. Again, we swap these over. We can't divide them and make the numbers any smaller. So our formula then would be FeCl2. Now what I would like you to do is take these bullet points down, copy this example, and also copy down this note here of what each of the Roman numerals represent. So I represents 1, I would be 2, I is 3, IV is 4, and V is 5. Pause the video here, take a note of it, and then we will move on to some more examples. So silver 1 nitride. We start off with the symbols for each of the elements involved. The symbol for silver is Ag. The symbol for nitrogen is N. Now this Roman numeral here tells us that silver's valency is 1. Nitrogen is in group 5 of the periodic table. That means it has a valency of 3. We then, as normal, swap the valencies around. So the 3 comes under silver, the 1 under nitrogen. 3 and 1 cannot be divided to make them any smaller, which means our formula then is Ag3N. Feel free to pause the video and make a note of this example, and then we can move on to the next one. Copper to oxide. So once again we are starting with symbols. The symbol for copper is Cu and the symbol for oxygen is O. This Roman numeral here, the 2 I's, tells us that copper has a valency of 2. Oxygen, being a member of group 6, also has a valency of 2. Swap them over, 2 and 2. Now we can divide 2 by itself to give us 1 and 1. So our formula then is CuO. Okay, so what I would like for you to do now is write the chemical formula for the following 10 compounds. You can find these 10 compounds in a Word document in the Assignments tab. You should complete this and then start the video again, and I will run through 3 more examples just to help you out. So pause the video, get this assignment done and sent, and we will go through some more examples just to finish off this lesson. So let's start with mercury 4 oxide. Our symbol for mercury is Hg, and the symbol for oxygen, as we've seen multiple times this video, is O. Our Roman numeral IV tells us that mercury has a valency of 4 and oxygen, which is in group 6, has a valency of 2. If we swap these over, like so, 2 under here, 4 under there, we can then divide these numbers both by 2. So 2 divides to become 1, and 4 divides by 2 to become 2. Our formula then would be HgO2. Another example then would be cadmium 5 sulfide. Now if we consult our periodic table, the symbol for cadmium is Cd, and the symbol for sulfur is S. Our Roman numeral tells us that the valency of cadmium is 5, and the valency of sulfur, which belongs in group 6, is 2. If we swap these valencies around, 2 moves under here, 5 under there. Now 2 and 5 cannot be made into any smaller whole numbers, so it stays as 2 and 5. So our formula then is CD2S5. Last example that I'm going to do today is copper 3 oxide. So copper, as we've seen before, has the symbol Cu and oxygen is O. The valency from the Roman numeral is 3 for copper, and being in group 6, the valency of oxygen is 2. We then swap these over. So 2 comes under the copper, 3 under oxygen. These numbers can't be divided and made into any smaller whole numbers, so they remain 2 and 3, which means our formula then is Cu2O3. And that, guys, takes us to the end of this rather short lesson on chemical formula using Roman numerals. If you are having any issues with this, please do not hesitate to get in touch with either myself or your own class teacher. Remember to complete the assignment for this lesson, and I will see you all in the next one. Have a lovely week. Bye, guys.